have like an introduction.
There we go. Introduction. What do you want to say?
Nice to meet you with Bond.
What's today's
I don't want people to know where I'm from.
What's today's
date? Might offend somebody. Today it's like May something.
It's May 21st.
There we go.
Ooh.
Alright, lipids. Lipids include fats and oils. Sometimes people use the word fat to encompass the whole category. Usually lipid is the more proper term.
But you did PowerPoint yesterday,
Yep.
and that's online.
The video is online. If I find a way, I might get like an Edmodo or something. I might start putting the PowerPoints on there too, so you can download them if you want. You guys all use that already?
You do Google Docs.
Yeah.
Yeah, you can do Google Docs. Yeah.
Is that easier?
Yeah, you can just upload it and then you share it and then we can look at it.
But don't you all have to have something to...
We have like the email from school, so you can just go on that.
So if I open a Google Docs and I share it, then what, you type in my email?
Yeah.
And then you'll be able to find
and you
my
share it
stuff?
to everyone and then we can find it.
Alright, we'll try that out. Alright, everybody got this? Fats and oils. That's what lipids are. I should make that like darker. Alright. Fats are found in animals. Usually when we differentiate between a fat and an oil, if it's solid at room temperature, we call it a fat. If it's liquid at room temperature, we call it an oil. Otherwise, in terms of formula and structure, they're not that much different. Oils, usually found in plants. Oils are usually liquid at room temperature. There's exceptions, obviously. I think coconut oil is solid at room temperature, so it's, I think that is right. Some of them aren't. So,
They are liquid or room temperature.
liquid, yeah, oils are liquid at room temperature. I should say
At
at
5.
room temperature. Thanks, Sarah.
I do like other periods not realizing this.
Oh, I just changed this one. I added some new slides. That was one.
How do you classify room temperature?
20 degrees Celsius, which is 68 Fahrenheit. But if you're saying Fahrenheit, you'd say 70, 75, something like that. You know. When you turn the fry lid off at night at McDonald's, the stuff gets hard, it's a fat. It stays liquid, it's an oil. Everybody got this? Alright, here's a fatty acid. Fats are made up of two parts. One part is the fatty acid. All these drawings, I'm going to give you the skeletal structure, and I'll also give you the old way with the carbons. So you can draw it this way if you like, or you can wait for the next slide and draw it the other way, whichever you're more comfortable with. You've seen these acids before. It's a carboxylic acid, and any of the ones that have long chains of more than 3 or 4 carbons maybe, we call them fatty acids. The short chain ones like acetic acid and methanoic acid, we don't call them fatty acids. Got this? So, if you're uncomfortable with this drawing, then I'll give it to you again the old way. So there it is, same thing. This is just drawing the old way. You guys want to wait for me to draw this, or you just want to keep the other one? Alright, if you want to draw this, I'll take a minute. Again, for worksheets, quizzes, tests, I don't care if you guys can do it this way or use skeletal structures. Bless
Let the board still.
Alright. The other part to a fat is glycerol. Here it is as a skeletal structure. Glycerol is also called glycerin. It's the stuff that's in your hand lotions, moisturizer.
Really up and down like that.
I mean, you could turn it sideways, right? I mean, it'd be like, you know, our textbook's really vertical. Well, it is right now, but you can turn it either way.
Did you just like not know how to turn that or something?
No, I made it this way on purpose, so when you see the next drawing, it'll make sense. Yeah. Well, not the next one, the one after that. When you make soap, glycerol actually separates from the rest of the fat, and it used to be that they would just kind of mix the two together and keep the glycerol in the soap, so soap would moisturize you. Then the companies realized they could scrape the glycerol off the top, make hand lotion out of it, and say the soap and lotion separately to make twice as much money. So that's why your soap doesn't have the same anymore. Unless you get the clear soap.
Dove does.
Some does, yeah. Some
Yeah.
The ones that are clear usually have glycerin in them. This is the same molecule, just drawn the old way. Look at it both ways. So what I'm going to show you in a second is how the fatty acids attach to the glycerol to make a triglyceride. Basically what fats are.
I don't know, make
Question? That's awesome. I was going to make soap for a lab. I was reading through the procedure and it said something like boiling 18 molar sulfuric acid, and I just decided I don't want to get fired this year. So.
Yeah, what is it called? I know she has to use that stuff that's really hot.
Actually, no, I'm lying to you. That was a different lab. Soap, you need sodium hydroxide and you need fat. So, that one was dangerous too, so I decided not to do it. The other one was for testing. Everybody got this? Alright, so here we go. Triglyceride. Here's what happens. Your fatty acid, 3 of them, will attach to the glycerol molecule. And right here, the OH will come off here from the fatty acid, and the hydrogen will come off here from the glycerol, and they'll go away. So a water molecule comes out, and then this oxygen will attach to that carbon, and that's where they're bonded at. And so all 3 of them attach, you get 3 water molecules come out. And you'll see a lot more reactions like this in chemistry, where there's a lot of ones where water comes out, and then water goes back in when you break it down. Write this down, but you don't have to draw this one. But in a second, I'm going to show you the whole triglyceride. I just want you to see this is where they bond at, this carbon to this oxygen. With molecules this big, it starts to become obvious why these skeletal structures are more useful. Because writing out things like this just becomes ridiculous. You don't have to draw this one. I'm going to show you another one in a second. Alright, everybody got this written down? Alright. So, here is the actual triglyceride. Now, you don't have to draw this one if you want. I'm going to show you another one with the skeletal structures. But there it is. The carbon from the fatty acid attaches to the oxygen on the glycerol, and 3 of them together, that's your triglyceride. Alright, so here it is. These are 18 carbon fatty acids attached to the glycerol. This is the skeletal structure version. So you can draw this one. these look different lengths. Each one of them is 18 carbons if you count. They just made these lines straight and these bent, so it looks like the top and bottom are shorter. They're all the same length. So this one, here it is, the regular version, the carbons written out. So these are the types of fats that are in your body. You don't have to draw this one out this way. These are the same thing here. This is just the long way. All right, some other lipids that are important here. Phospholipids are the ones that make up your cell membrane. Show you a picture of them. Waxes are also lipids. Esters, so that phospholipids, we've got two pieces, two fatty acids attached to this head that has a phosphate ion on it. And the head is charged. It's got a positive here and a negative here. So because it's polarized, the head is attracted to water. The tail is a long chain of carbons, not attracted to water. So when you put a bunch of these in water, they just naturally tend to line up. And in the center you have the tails that push water away. They don't really push it away, but the water is attracted to the outside. And so water tends to stay outside of both sides. And so this is what you see for a cell membrane in the cells in your body. And they keep things that are dissolved in water from going through because they're not attracted to the middle, they're only attracted to the heads. So you need something that's not attracted to water to go through the center there, through the layer. Anyway, all I really want you to remember, phospholipids are used in cell what your cell membrane is made out of. So make sure you have that. Questions? All right, we are done. Lights or no lights?
No lights.
All right.